Okay, right into activity 5 now. So the students in the last activity have learned a little bit about, why we care about particulate matter and why they should care about, their exposure to it. In activity 5, so this is all these activities really leading up to the air beam activity, which is activity 6. So that's also a really, really fun activity. The students are really into the technology and collecting data. But before they get there, we want to teach them about, how do we measure particles? And so in this activity, the students will be thinking about ways to measure particles and then also be doing some fun dimensional analysis and math and calculations here. So we'll be teaching them about the instruments that measure the mass of particles and the volume of air, and then they'll be computing a concentration. So I'm going to refer to this as the mass over volume method. They'll also be learning about light scattering instruments, which includes the air beam that they'll be using in activity 6. And then the materials that they'll be using for this lab are a vacuum, a snazzy handheld vacuum. All right. So activity 5 starts on page 65 in my teacher's guide. And before I get into the slides that I'm presenting here, there are some pre-lab guiding questions which have the students, think physically about the units that they're going to be working with. So one of the questions, pre-lab guiding questions, which also, by the way, this is a page that only the teacher sees, but I think it's really important, to have the students think about this. How large is a cubic meter? What does that mean physically? And so there's a recommendation, to have the teacher use 3-meter sticks to display, show a box of that size. If they have a box of that, a cubic meter, that's even better. But this, helping them understand physically what a cubic meter is I think, really important. Similarly, they're going to be thinking about, pre-lab guiding question, how large is a microgram? A microgram is 1/1,000,000th of a gram, and I don't know if I understand what that means physically. So to have the students think, if they have a balance and can weigh out 1 gram or even a smaller amount of material, and then think about how much, what a microgram is compared to that gram, I think that really helps when trying to do especially unit related work. All right, so in this activity, they're going to learn about the mass over volume way to measure particles. And so this is something that probably a lot of us in this room are familiar with. The air is going to be drawn, a lot of the regulatory instruments work this way. Air is drawn into an instrument where anything in that air mass is deposited. There's a filter there, and the air will be pushed through the filter. And anything in the air mass particulate matter will be deposited on that filter. And then the second part of this equation, so the volume part, is the amount of air that's moving through the instrument in a certain amount of time, knowing the volume of that. And then afterward, you have your filter, which has a certain mass on it, and then the volume of air, and you can divide those two quantities to get a concentration of particulate matter. And these are, so this slide is also an example. These examples aren't included in the workbook, but I think it would be really cool to show the students examples of the instrumentation that we use in a regulatory sense. So The image on the left is I'm actually not sure what instrument that is, but that, what we're looking at there, there's a cycle, is a Teledyne T640. Thank you, Hillary Hefner. So the air is drawn through the top of that. Can anyone maybe do some pointing for me? The cyclone is drawn through the top of the instrument there, and it travels through the tubing, and the gray box at the bottom contains the filter. So the particulate matter is deposited on the filter paper within that instrument. And on the right here, I have two examples, one which you've seen before of the wood smoke and diesel-related combustion. But then on top, there's another example of filter paper with smaller circles and more frequent circles. So one thing that I think would be interesting to talk to students about here, especially since they're going to be using sensors, which are much smaller and take measurements at a much higher frequency, is the difference between the sensors that they're going to be using and the regulatory instrumentation in the field. So the larger filter samples at the bottom, those are 24-hour samples. You're going, that's sitting out in the field for 24 hours with air moving through the filter continuously. It gives us a lot of information, but also, when we get the results back from the lab, we don't have any information about what the air quality was like at noon. So, it's a 24-hour average. It doesn't give us very much temporal resolution. Alternatively, the sample, the filter tape above that is an example of a 1-hour measurement. So you have a little bit more temporal resolution. What the air quality is like at noon, but it's, you're not getting results that are any finer than that. The other thing about the regulatory instrumentation that we use is it's stationary, right? So it's in one location, and we often don't have a very high density network of these regulatory instruments because they're expensive. They're also very large. But the data quality that we have from these instruments is really high. A lot of research dollars have been put into creating these instruments, and we really have high faith that the data that we are seeing from them is accurate. All right, so I'm going to do a small demonstration. I'm not going to do the whole activity here, but I'll walk you through the basics of this before I start talking about light scattering instrumentation. So this, like I said before, this activity uses a vacuum, a handheld vacuum, and if you can, use the plastic bag that you used before, or put them on plastic weights. I believe this bag is 3 gallons. We have that on the reusable, or on your kit. earlier this week, and the second time worked out a lot better. So I'm going to try again.
Should have been about 3 seconds.
Yeah.
And I got 11 seconds.
So this is also another activity that works really well with many people. Helping hand teams are really good. So fill the bag of air again, and I'm transferring it onto the vacuum. I have a pretty good seal, and then I think this time I'm going to hold up the bag here so it doesn't. Last time I think the back part of the bag got stuck into the vacuum, blocking the air. So ready? Round 2. So 3.5 seconds. So we had 3 seconds earlier this week. It's useful to do it a few times to get a few data points. Maybe take an average then. But yeah, well, that time worked a lot better. The vacuum, the bag didn't get stuck into.
Don't you think it's useful though to show how it might fail, so that then you know, oh, no problem, I'll just do it again and get fun. Because if we were doing it perfectly every time, it's sort of, that's not realistic. So it's hard to do.
Yes, and as I said before, I've had a lot of practice with these activities. Your students will not have had as much practice, so they're probably going to need to familiarize themselves with the process. Right. The other component of this activity uses the filter for the participants. And what they're going to want to do before they start taking questions. So they're going to be tracking the filter to
I'll just add that for all of these hands-on activities, we typically recommend that the students work in groups of 3 to 5, depending on the class size, obviously. And we're actually running a little bit ahead of the schedule, so we're going to take about a 10-minute break. Yeah, in between this activity and the Airbnb.
So this activity 5, the vacuum activity, is going to help students understand the mass over volume collection method of measuring particles. But in this activity, they're also going to learn about the light scattering method of measuring particles, which is what the air beam uses to measure particles. So this is an example of an old air beam. The air beams no longer look like a mouse. They now look like ghosts, which is pretty exciting. But this one is broken, and we like to use it to show you what is inside what the guts look like. So in a light scattering instrument, air is drawn through the instrument by a fan. So it would enter the instrument here, and then it's drawn through a cavity here, which has a light. So there's an LED on the side, so there's a laser or a light that's going to shine into the cavity where the particles that have been drawn in to this instrument by the fan are. And the light's going to scatter off of the particles, and then it's going to be detected by a photodetector on the other side. So that photodetector is really measuring the intensity of light of the particles that scattered it. So the more particles that you have in your instrument, essentially, the more light scattering that you're going to see and have detected by your photodetector. Okay. But these instruments, that's not really giving us a concentration. So light scattering instruments are usually run side by side with the regulatory instruments that I showed earlier and have talked about. So scientists and researchers can equate, how does light intensity scattering, the light scattered, how does the light intensity relate to concentration of particulate matter? And in this case, the makers of the air beam have run, the air beam side by side with a dust track. I don't remember. And all this information is actually on their website, which we'll show you after lunch. But they use that equation, that relationship, to understand how the light scattering of the air beam relates to concentration of particulate matter. And if anyone's interested, this is up here if you guys want to take a look at it. It used to actually run, but I think it's finally run out of batteries. Yeah, so that is the last thing I have, and I guess now a 10-minute break would be useful.